Hello and welcome to Lesson 2 of Simplilearn's Exam Agile Scrum Master Workshop. After completing this lesson, you will be able to explain the features, strengths, and limitations of software development using approaches including the traditional waterfall approach, as well as various agile methods including lean, extreme programming, crystal, and DSDM. You will also be able to describe the role of DevOps as a discipline that is critical to the success of Agile teams. You will also understand how to apply Agile methods to IT service management. Any method which is incremental and iterative is inherently Agile. Under the Agile umbrella is a family of methods including Scrum, extreme programming, also called XP, Crystal, Kanban, Lean, feature-driven development, and DSDM. All of these methods share Agile practices and values like embracing change, lightweight or lean documentation, daily stakeholder collaboration, incremental delivery, and continuous improvement. Before we talk about some Agile methods, let's review the traditional software development lifecycle when using Waterfall. This approach is called Waterfall because of the series of steps that are used to create the final product. You can see that the initial step is to collect all of the requirements necessary. That's followed by the design phase, which is where the software structure is determined. Then in the implementation phase, the software is actually developed. In the verification phase, the software is tested both for correctness and acceptance. And then, of course, once the software has been deployed, there's the maintenance phase. This traditional approach is perfectly suitable and logical for project management. However, when it comes to software development, where there's a high level of complexity and uncertainty, the challenge is dealing with change. Change is not only difficult, it's very expensive. For example, if you discover a critical design flaw during verification, or if the requirements change during implementation, the amount of rework needed to correct these can be prohibitive. The results is a tendency to resist change, which in turn compromises the spirit of customer collaboration. Nevertheless, if you have a project that is very clear in terms of its requirements and is unlikely to experience too many changes, Waterfall could be a reasonable and effective approach for projects to simply migrate features or products from one platform to another. Keep in mind that both the problem and the solution must be clear for this approach to be a good choice. Now let's look at a few Agile methods and see how they are likely a better fit for projects that are complex and uncertain, like software development. Let's turn our attention to extreme programming. XP was developed primarily to respond to the high cost of changing requirements and establish strong engineering practices to improve the quality of software and then take them to the extreme. For example, if testing is good, let's do unit testing, integration testing, and acceptance testing. If design is good, let's do design all the time and make sure we do retrospectives at the end of each iteration. If simplicity is good, let's eliminate anything that does not add value and make sure we always do the simplest thing. If review is good, let's continuously improve by making sure we do reviews and retrospectives at the end of each iteration. If communication is good, let's make sure our team space and tools encourage face-to-face and osmotic communication. If using short iterations is good, let's make sure we get regular stakeholder feedback in order to improve the quality of our software and make sure we're delivering the value the customer wants by doing the shortest possible iterations. XP introduced a number of revolutionary concepts to software development, and many have become standard practices. Perhaps you recognize some of these practices. Test-driven development. This is where the team writes the test before developing the code. Continuous integration. This is the practice of regularly integrating new code into the system and using automated testing to determine the status of the integration. On-site customer. XP essentially made the customer part of the team. The customer is expected to be on site and participate with the team on a daily basis. User stories. This practice is a quick and effective way to capture customer requirements and make sure there is agreement between the customer and the developers regarding what's to be developed. Other XP practices include creating a coding standard for the project, collective code ownership, pair programming, establishing a sustainable pace forever, creating a system metaphor to increase communication effectiveness, as well as others. XP teams have the following characteristics. They are self-organizing. Teams are empowered to decide for themselves how they're going to execute the work of the project without top-down management and control. They are cross-functional. The idea is to have generalizing specialists as team members. These are team members who specialize in one area but have enough knowledge to participate in the other roles that are part of an XP team. They compromise and collaborate. Team members, including the customer, the coach, the programmers, the trackers, and the testers, collaborate in order to reach agreement on exactly what needs to be developed. XP roles fall into three different categories: customers, programmers, and testers. Customers are the business experts and can include product managers, domain experts, interaction designers, and business analysts. Ideally, there will be 2 for each 3 programmers. Programmers are the implementation experts. As we said, they are generalizing specialists, meaning programmers can exchange roles as necessary during the execution of the project. Ideally, there are 6 to 10 on a team. Testers are the quality experts and focus on unit testing, integration testing, acceptance, and exploratory testing. There are ideally 1 for each 6 developers. The Crystal method was developed by Alistair Cockburn and was designed for projects ranging from small teams developing low critical solutions to large teams developing critical solutions. The 4 levels of criticality in Crystal are comfort, discretionary money, essential money, and life. Depending on the criticality level of the project, there may be an additional need for verifications, validations, and traceability measures. The 7 key principles of Crystal include frequent delivery, focus, reflective improvement, ease of access to experts, personal safety, technical environment, and osmotic communication. Now let's talk about DSDM. DSDM stands for Dynamic Systems Development Method. It was developed in the 1990s and is a comprehensive method documented in the form of an ebook that is available freely at the URL below. DSDM links well with conventional project management techniques like Prince2, making it quite popular in the UK. DSDM embraces 5 key principles. Involvement is necessary in order to develop the right business solution. Requirements may evolve, however, the timescale is fixed. This is the concept of time boxing, which we will explore in more detail later in the workshop. Early delivery, because it results in early return on investment from the value created. It's implemented based on the 80-20 principle. This is based on Pareto's 80-20 rule, which in this context suggests that 80% of the value is going to come from 20% of the features. Nothing is built perfectly the first time. It's futile to think that perfection can be achieved the first time. Rather, the best solutions evolve through iterative development. In the traditional planning approach, the scope is fixed and the schedule and budget is variable. However, in DSDM, that's flipped upside down, so the schedule and the budget are fixed and the scope is variable. This means that the project will end once the schedule and budget constraints have been met. The 80-20 rule is used to establish a guaranteed minimum usable subset of features. And then if there is remaining schedule and budget capacity, additional work can be done. The 5 core techniques in DSDM are iterative development. This, of course, is the evolutionary approach to software development that is a founding concept in Agile. Time boxing. Time boxing is the technique where the amount of time for the duration of an activity, a meeting, or an effort is fixed. In DSDM, iterations are time boxed, and once the duration has been established, it is never changed. Moscow prioritization, where M stands for must, S stands for should, C stands for could, and W stands for won't. The items in the product backlog are prioritized where M's are the must-haves, S's are the shoulds and are highly desirable, C's are those things that would be nice to have, and the W's are the won't items. Those are the things that do not add value and should not be developed. A facilitated workshop is a collaborative event in which the participants focus on creating, correcting, or documenting a solution or deliverable. In DSDM, facilitated workshops are used primarily for planning efforts. Modeling is a discovery technique used to create the best solution for the requirement or feature. Okay, so now we're going to talk about Lean. The genesis of Lean software development is in Lean manufacturing, which originated with the Toyota production system. Tom and Mary Poppendieck applied Lean manufacturing to software development. This method focuses on the elimination of waste, irregularities, and overuse, and includes the following principles. Eliminate waste. Anything that does not add value to the customer is considered waste. Amplify learning. Learning is amplified by using short iterations, refactoring, and integration testing, as well as frequent customer feedback sessions. Decide as late as possible. The best way to manage uncertainty is by gaining information, minimizing assumptions, deferring commitment to the last responsible moment, and breaking dependencies between components. Deliver as early as possible. Short iterations or small batches provide valuable feedback opportunities and allow for effective decision making. Empower the team. The team is the source of decision making, and management turns to the team to understand the best options and their costs. Build integrity in. Ensure that quality is embedded throughout the system by requiring automation of testing through builds, installs, and continuous integration. Lean software development can be summarized as follows. Think big, act small, fail fast, learn rapidly. Waste can constitute up to 90% of a process. Therefore, we must be constantly looking for ways to eliminate it. Mary and Tom Poppendieck contrasted waste in manufacturing with software development and came up with the following types of waste in software development. Overproduction looks like extra features. Excess inventory looks like partially completed work. Unnecessary processing looks like extra processes. Unnecessary movement of goods looks like task switching. Unnecessary movement of people looks like endlessly splitting resources across teams. And then waiting time and defects are the same in both manufacturing and software development. Kanban also has its genesis in the Toyota production system. Kanban, a Japanese term for signal board, is used to manage the throughput of processes by identifying bottlenecks, setting work in progress limits, and displaying the status of the entire process in one view. In a Kanban board, the value chain, or the steps in the process, are represented by columns. And as capacity is available, or the need arises, items are pulled from the left to the right across the columns in a just-in-time manner. Kanban uses 3 steps. Visualize the workflow by creating columns for each step in the process. Manage the flow by minimizing the work in progress. And continuously improve the process by applying Kaizen principles. DevOps is an emerging discipline that is fast becoming a critical element of Agile methods. Let's take a look at how and why it works. In short, Agile teams develop functionality and create value for the business. Operations teams are the interface with the business and take over this functionality from the development team. Then they deploy this functionality into production, and that is when value is realized by the business. We can see here how a dev team delivers valuable features sprint after sprint after sprint. However, the operations team is only able to deploy them once every 3 months. In other words, much of the value that was created by the development team was on hold and not able to be realized by the business. What DevOps does, as you can see here, is it combines the dev and ops teams into a synergistic process that ensures quicker deployment of the value created by the development team. Ops teams are involved right from the product envisioning to initiation to building to testing. They provide the non-functional requirements and provide the infrastructure necessary for deploying the system up front. As soon as the dev team has completed working software at the end of a sprint, the ops team is ready to take over and set it up, ideally in an automated fashion. In short, DevOps is the science of moving code from development to testing in a staged environment to production, or in general, from one environment to another in an automated and efficient manner. Agile teams cannot do this without strong support from DevOps. DevOps is supplemented by a strong tool set related to build and deployment management systems. Our discussion about DevOps leads us to another important thing. The systems development by Agile must ultimately be transitioned into operations and be integrated into the services that IT renders to the business. These services are managed and delivered through IT service management, which is governed by ITIL practices. Just as we need to get ops working closely with the dev processes, we must also connect the ITIL lifecycle with the development lifecycle. The product owner brings up a product requirement in the form of an improved user story or epic with a business case, which must also become part of the overall IT service strategy. The transition of the features into the sprint backlog must be aligned with the design of the service. As the Agile team is developing the feature, the service transition plan must be in place so that the developed features can be integrated into the operations in a smooth and seamless manner. Agile and ITIL roles must either be combined or they must collaborate closely to enable smooth transition of products into the service management world. Looking at the top left, the service owner and the product owner could either be the same person or they must collaborate closely to clearly represent the customer's needs. When a product is deployed, it transitions into the delivery of a service to the business, and the end-to-end understanding of the life cycle enables clearer visualization of customer value. The product owner must either be part of or lead the Change Management Advisory Board, or CAB, because the product owner is responsible for determining the priority of user stories and releases. Just as the Scrum Master is working with the development team to continuously improve the development cycle, the Continual Service Improvement, CSI, manager works to ensure the services linked to the products are also improving. If there are any issues across the value chain, the two must collaborate to ensure that they are constantly being reviewed and improved. Let's summarize the topics covered in this lesson. The traditional waterfall approach is logical, however, change is cumbersome and expensive. When it comes to agile methods, Crystal is strong on communication, DSDM is good at time boxing and prioritization, and XP has robust engineering practices. Agile and Scrum techniques have to be complemented by DevOps processes in order to ensure that the value developed can be deployed quickly and seamlessly. Agile and Scrum should also link to IT service management because products are ultimately tied to business services supported by IT operations.